I believe we have a panel to kick things off with your good self, Glenn.
Absolutely, that's right. So the first event that we have today is a panel. It's with 3 different speakers. So I'm in there, and I'm the main person present here. We have also Bo Zhang from Meituan. He wanted to make the trip out to Madrid, but he wasn't able to due to some visa issues. And then we also have Yonatan, who has been out here. Yonatan from Deci AI, which is a great startup based in Tel Aviv. They've raised, I think, a lot of money, $50–70 million. And they've got some really cool tools, I think originally in the CV space, but I've seen them also now branching out to other things, diffusion models, and also LLMs.
Sweet. Okay, now I'm obviously much less informed on the space of vision AI than probably anybody else in the room, so I will be reading from my notes if you don't mind. A few other things to mention about our amazing speakers. I mean, Glenn's given them an awesome intro there. I'm just going to fill in a bit of details. So Bo Zhang is an algorithm strategist at Meituan Vision. He received his master's degree in informatics at the University of Trento, Italia, molto bene, in 2013, and his previous efforts have been put into automated machine learning and computer vision. He has collaborated rigorously on the YOLO-v6 project, and Meituan are the creators of YOLO-v6. And Glenn, do you want me to give you a bit of an introduction? So I think the people here should know a little bit about what you've done and what you're doing. So,
oh yeah, sure, yeah, myself. Okay, yeah, no, I'm pretty qualified to do that. Yeah. So I'm Glenn Jocher. I'm half Spanish, half American, and I've been here in Madrid for the last 4 to 5 years, just working on YOLO. Before that, I did particle physics. Before that, I did aerospace engineering. I wanted to be a pilot, but it turns out I'm terrified of flying. And I've really kind of found my stride here in AI instead.
Outstanding. Particle physics. You could have picked something hard. I don't know. Wow.
That wouldn't be very fun, though.
I know, amazing, amazing. And we're delighted to be joined as well virtually by Yonatan Geifman, who's a co-founder and CEO of Deci. And this Deci, if you don't know, is the deep learning development platform. And before co-founding Deci, Yonatan was a member of Google AI's MorphNet team. He holds a PhD in computer science from the Technion Israel Institute of Technology and a Bachelor of Science and a master's degree in computer science from Ben Gurion University in Israel. His research focused on making deep neural networks, DNNs, more applicable for mission-critical tasks. And it has been published and presented at leading global conferences, including the Conference on Neural Information Processing Systems and the International Conference on Machine Learning. So Deci are the creators of YOLO-NAS. So I hope you'll agree, we've got some real rock stars joining us in person and online right now for a bit of a deep dive into the world of YOLO. Hashtag YOLO, hashtag YV23. Please remember to share the love. Okay, we got Yonatan there. Fantastic. We got the back of my head. So let's grab a seat there. Should we grab a seat there? Do you want to grab a seat? Yeah, let's do it.
Let's do it.
And then we're going to have Bo is going to join us as well, I believe. Okay, so Yonatan, can you hear us okay?
Yes, can you hear me?
Yeah, absolutely. The technology is seamless, but I really would expect nothing less from Google for startups. Do we have Bo joining us as well? So at the back of the room, just throw something red at me, if not, and throw something green if Bo is joining us. Okay, we are, so just a reminder that please do remember to share the love on LinkedIn and all of the social media platforms. YV23 is the hashtag, and we would be delighted to share your thoughts and amplify them through the official channels. So as we kind of wait for confirmation of Bo, I think it would be interesting, Glenn, to kind of, if you could paint the picture, this is an ecosystem that you've built. You've been working on this for like 5 years. This has been a big mission. And I'm a great believer in the idea that, you know, if you want to go fast, go alone. If you want to go far, go together. But if you want to go fast and far, you go as part of an ecosystem. And this is exactly what you've built here. And you've got 2 key members of the ecosystem. So Bo's joining us. Hello, Bo. Great to see you.
Hey,
fantastic.
Oh, hi, Shane, Glenn, and Yonatan. Thanks to everybody. We finally met at the second year. It's great to be here.
Fantastic. Glenn from Madrid. Okay, so we're going to jump right in. I have some questions here. I'm very curious to know the answers. So I would love to know, now I guess in order of virtual appearance, I'm going to send this to Yonatan first. So what challenges did you encounter during the implementation, and what did you prioritize most in its creation? So that's your good self.
Yeah, thank you. So at Deci, we're very focused about the performance of the algorithms, like everyone walking on the edge, and those YOLO's models are mostly running on the edge. So we try to build to squeeze out the maximum performance that we can from the GPU, but together with that, kind of keeping the simplicity in usage, like we saw great examples from prior algorithms like YOLO V5, V8, V6, that all of their creators are here. So we try to build something that will be more performant in terms of the accuracy latency trade-off, but still will keep the simplicity and the generality of the YOLO models that already existing, because we built like as part of that series of YOLO. It was kind of a trade-off. How can you bring the best performance to the algorithms, but keeping them simple and that can generalize for many types of use cases and data sets and things like that. And that was kind of the trade-off. I think that the last test for us was going through the rubber flow test that Glenn also used initially with the YOLO-V8, and testing how we perform on like, I don't know, maybe there's hundreds of data sets over there. So how this model will generate for hundreds of data sets, and we were very curious to see like how it will perform. And that was the last stamp for us, that the model that we've built is able to generalize for different types of tasks while keeping the performance high.
Fantastic. Okay, that is like a glimpse right under the hood there for YOLO-NAS. And coming over to your good self, Bo, talk to us a bit about some of the, challenges that you encountered during the implementation of YOLO V6, and what did you prioritize most in the creation? You all make it sound easy to the layman here, so I'm very impressed. But Bo, what's your kind of insider view on the progress?
Thank you, Ocean. So to start off, I would take a little bit to add some introduction about my company. So Meituan is the largest instant delivery service provider, primarily food in China. So we connect service providers like hotels, restaurants, stores to the customers. We build the underlying AI infrastructures to provide steady support to all these online services. So as of YOLOv6, some of the main challenges during the creation include the design of algorithms and the optimization of it as well. Apart from that, also invent new training strategies on top of the, let's say, the standards that are set very high by previous YOLO versions. So finding the right balance between the accuracy and efficiency is crucial. Also, for the optimization purposes, the architecture have to be designed as quantization friendly. In terms of priorities, we think that the most important aspect is to ensure performance and reproducibility. Considering the high standard that is set by the YOLOv5 and its brothers and sisters, so we have to ensure performance and its reproducibility to make our YOLOv6 robust and be able to accurately detect objects in real-world scenarios compared to all its counterparts. Thanks.
Excellent. Thank you, Bo. That's very, very insightful. And you can see there, like the ecosystem is dealing with different points on this, YOLO journey that we're all on together. And Glenn, bring us into that Ultralytics perspective there and talk to us about YOLO-V8 and how did you prioritize to make that great progress that's been happening?
Yeah, absolutely. So I guess if I take a step back, my journey really started in ML with particle physics. I initially tried to apply it there to a few problems, and I did not do very well. And this sort of guided my thinking when I started working on YOLO models. And so I wanted the models to be less of sort of an academic pursuit, less of a laboratory research, and more of a real world product. And what I saw was that there were a lot of academic papers published with benchmark results on just a given data set. But there wasn't really somebody thinking about how to connect that dot to the second dot, which would be using that in the real world, getting actual value out of it, whether you're like a student in school or whether you're an enterprise trying to save money or make money in a product. And so I was very focused, maybe I'd say obsessed, with making this kind of like a real world solution. And because of that, I really focused on other parts of the trade-off, not so much speed, accuracy, and the traditional sort of benchmarks that you think of when you look at, say, the latest accuracy coming on the COCO data set. but I thought of real world data sets. And so what often happens is people will really want to apply a machine learning solution with insufficient data, with poorly labeled data sets, with few resources that they want to run on the edge. And so when you look at this is really a different problem than somebody who's, say, pursuing a PhD in machine learning and maybe looking to develop a new module or a new architecture to kind of get like a slight boost in performance. So oftentimes, just small changes in other parts of the code to improve the usability, the deployability, to perhaps have the model generalize more often on more common data sets. And so there's been a few steps in this direction. Yonatan mentioned the RF100 data set, which is really interesting. RoboFlow's launched this. It's a collection of 100 real-world data sets. It's a bit larger than the COCO data set, but benchmarks on this lead to better indicators in typical real-world circumstances. So I guess a great example is COCO has, say, giraffes, and just most of the time people don't really need to detect giraffes, but they need to detect other things, and these more common data sets are one of the ways to do that. I think the last part was that when I moved from YOLOv5 to YOLOv8, the YOLOv5 project that I'd started, it started developing a lot of traction. And so over time, I lost a bit of freedom. I wasn't able to just change what I wanted like overnight because a lot of people would complain. They'd say, Glenn, I was using this model in this workflow. Suddenly it doesn't work anymore. What did you do? And I'd say, oh, no, that's actually an improvement to make your workflow easier. And so but they say, no, but everything's broken. You just, you know. So then I realized that I needed to be much more careful. And so my journey went from sort of the research side and just sort of like the hobby side to more and more looking at this from like an ML ops perspective and kind of respecting the established use cases and like the embedded solutions people had already created. And so over time, YOLOv5 has been out for 3 years now. I launched it in May 2020, and I lost a little bit of room to maneuver. And so there were a lot of changes I wanted to do to it, and I just couldn't. But I started saving those little by little, and I'd accumulated a nice basket of changes, improvements, not just to the model architectures, but almost even more importantly, to the training, to the user front interface for how you would use the models and how you would deploy them. And we saved all of those, and I worked with a couple other researchers, Ayush and LQ on GitHub, to create this into YOLOv8. And of course, we also looked at the latest research. We looked at YOLOv6, YOLOv7 also by Alexi AB, and we baked in all those improvements, and we rolled this out as YOLOv8 earlier this year. So for me, the most exciting part is just that it's easier to use, it's simpler to use, it's pip package native. And a lot of those things I think contribute more to me than just like a few architecture changes, which are also important though.
Fantastic. Well, congratulations on the brilliant kind of collaborative effort. And you're speaking there about that transition between it being like, you know, you had a lot of ownership, you know, you kind of had your arms around it, and then you have to involve more and more people the further it goes. And of course, that is the balancing act with anything open source. It's about collaboration, it's about community. But, you know, staying with yourself, you know, are there any kind of bits of advice or learnings that you have now from that process of managing all of that community input and kind of managing, you know, the quality, the creativity, and encouraging that kind of open source ecosystem development?
Yeah, absolutely. So I think I've heard a quote from Elon Musk that the limiting factor for any progress is the speed of iteration. And so you mentioned earlier, I think you said you can move fast by yourself, but you can move far with other people. And so initially I moved very fast, and I would get feedback online through GitHub issues. So about 5 years ago, I'd never done open source. It was kind of scary. I thought people would just run off with your work, and that's true. But they also help you with your work. They contribute. They give you feedback. And that's been incredibly valuable. And my own personal iterative cycle was incredibly short at the beginning because I would just see something that somebody mentioned that they could improve on, and I'd just do it. And so like within a few hours, it'd be done. I'd release it. If there's a bug, I'd fix it the same day, and so on. And that's, I think, one of the key reasons that YOLOv5 progressed as fast as it did. That's kind of hard to replicate at a larger enterprise.
Yeah, fantastic. I mean, it is such a balancing act. It's such a kind of specific art about balancing these kind of global contributions. And I think, you know, all of you on the call arguably have used technology and distributed technology in a very innovative way to bring the best possible results to your collaborative open source projects.
Yeah, and by the way, so I should definitely mention, so it's not just myself or the team at Ultralytics. We have over 500 contributors on GitHub. and they've been invaluable. They've helped us fix bugs, introduce features. You can't be an expert in everything. And some very large parts of YOLOv5, for example, were contributed entirely by third parties. Like, for example, the TensorFlow export there, all of that was done by another contributor. So I think it's the team effort. It's you putting out your work and other people using it, but giving back. And giving back's incredibly important.
Tremendous. So big shout to the 500 contributors there.
Thank you. Yes.
Absolutely brilliant. And TensorFlow introduction there. Wow, what a great project to be a part of. So just coming over to our good friends on the virtual screens there. I mean, Yonatan and Bo, do you want to kind of add anything to that area of collaboration and managing the quality? Did your kind of projects mirror that same kind of vibe as Glenn's here in the Ultralytics distributed project there? Have you used the same tools? Have you found anything different? Who'd like to jump in there? So Bo, you're nodding your head, so I'll take that as volunteering.
Thank you. So active community involvement definitely it is the key to an open source project's success. We primarily rely on GitHub for maintenance. As of this month, there are almost 500 closed issues and 250 merged pull requests. Apart from GitHub, we benefit enormously from the WeChat group that we targeted at our users and contributors. We share news from the research frontline, as well as our next steps, discuss bugs, features, use cases, etc. All done on mobile. So this creates a direct and inclusive and more responsive environment for every participant in the community. It's indeed challenging for quality control and compatibility management. So we first go through a review process for all the pull requests going on, and the core features like architectural design, training mechanism are mainly internally driven. So in the future, I believe it would be important to put up some detailed contribution guidelines and criteria for implementation. I'm so delighted to see deeper involvement with the community, so that we're no longer limited by primarily internal demands therein. So, thanks.
Phenomenal. That's great stuff, Bo. Absolutely brilliant. And Yonatan, how about your good self? You've been leveraging GitHub a lot over the evolution of the NAS project.
So we're the youngest project on that. Like, we launched YOLO-NAS on May or something like that. So we are now mainly working on improving the repo and getting feedback by the issues and things like that, because we're just learning how to handle all that support and feedback from the community, and how to manage the backlog and things like that, because it's relatively new for us. But all feedbacks are getting feedback is great. Having pull requests is great. In improving the repo and the model step after step is what we are working on at the moment.
Nice. Okay, and now it's time to talk about kind of getting faster, putting go faster stripes on all of the tech. So we've got hardware acceleration, we've got the evolution of GPUs and TPUs. So how do we see YOLO models leveraging these new technologies for even better performance? Who wants to jump in there? Let's talk hardware acceleration. Yes, Glenn.
I'll jump in because this is a really exciting time to be alive. So the AI theories that were first proposed in the 60s and the 70s were completely unworkable at the time, right? And you could kind of put pen to paper and write out some equations, but other than that, it kind of stayed at the theory place. And only recently, I'd say around 2010, in the middle of that decade, did the hardware begin to catch up. And this is when we saw this kind of amazing explosion in adoption, in potential. And because of that, I think right now is just a great time to be an ML, to be an AI, to contribute, to kind of make your mark right now. I think, for example, if I was trying to do this 20 years ago, I'd have a very difficult time. So it'd be very frustrating. But now the hardware has caught up to the software, and now the algorithms are getting a lot of attention. And the combination of all three is really just a very powerful synergy that we're seeing at the moment. And it's only going to get better, which is really exciting. To give you guys just a quick example, when I first started working on YOLO, I wanted to show people what I was doing. So I created an iOS app. I called it Eye Detection. I put it on the store. And it was terrible because the iPhones could barely run it. So even like the smallest YOLO model, it was running like 1 frame per second. And it was just a terrible user experience. And I think that was only like 3 to 4 years ago. And now it's just very fluid. It's real time. And even the largest YOLO-V8X models can run real time on your phone. So the hardware is making amazing strides, not just NVIDIA GPUs, but edge devices also. This is through like minimization of process nodes. I think we're down to 3 nanometers now, which is incredible. Moore's law is apparently still in effect, which is good. Maybe not in the coming decades, but for now, I think we're still there. So I think we can continue to expect more improvements.
Oh, that's wild. And you just kind of mentioned that, progression of technology. I was just thinking that the first kind of smartphone, quote unquote, I got a million years ago. I'm old enough to have had a Sony Ericsson P800 with a built-in stylus, and I can't even remember what painful operating system it has, but it was miraculous at the time. And then when the iPhone comes along, it's like all of that melts into the background. This is the new normal. And now we've got hardware acceleration, and this is the new normal. And the science, the dreams of the scientists and the programmers from the past is now becoming a reality. So this is very, very cool.
At the end of the day, you need a lot of processing power to run AI algorithms. Even the YOLO models, which are among the smallest and the fastest, you still require many flops. There's still many millions of parameters. So
mind-blowing stuff. I'm so glad you're all working on it. This is great. It's very reassuring. So listen, I would like to move on to the next question. And what we're kind of going to look at now, so I don't know who wants to jump in, is all about object re-identification. So this is gaining a lot of popularity in recent times. Are there any plans to integrate modules for object re-identification in the near future? Who's excited about object re-identification? Okay, Glenn.
I'm excited, but
well
maybe I'll let somebody else take this one since I got the last one.
Okay, Yonatan, Bo, who's going to jump in on that one? Yonatan.
Yeah, so that's definitely one of an interesting real life or scenario for using object detection, or another model for adding on top of object detection. We're seeing like object tracking and Re-ID and all of those technologies. Basically, we can think about the YOLO algorithms as a backbone that we can plug many other applications on top of it, which one of them is Re-ID, object tracking, semantic segmentation, pose estimation, and many other like fine-grained tasks on top of the YOLO backbone. And we're working task after task to add support and also we're getting support from the community. So for example, we have an object tracking repo that is taking YOLO-NAS and running object tracking, post-processing algorithms and things like that. So basically, all of those can be added on top of any YOLO model, and it's great to see like how those models become kind of a toolbox that you can take it and build on top of it, and get other tasks to be solved, like segmentation, which I think that YOLO-8 has, and other things like Re-ID.
Yeah. So we've to build on top of that. Let's see. We've actually built tracking like directly into YOLOv8. So you can just, if you pip install Ultralytics, you can just run YOLO track, pass it a video, and it'll work. And we don't have kind of long-lived Re-ID, but we do have a bit of sort of like ethereal Re-ID. And so if you're just gone from the frame for like maybe like a few frames, like if you're gone for like 10 frames and you pop back in, we should be able to like see that it's you again. But again, this is sort of like in the baby steps. I had a call with a club manager in Brazil, and he showed me like a video of a drone flying around the club. It's like thousands of people, and he's like, "Glenn, I want to count all these people with YOLO." And the drone was just going everywhere, and I was like, all right, you're gonna like, it's looking this way, and then it's looking that way, and like ideally you want to like not count the same person twice. So for something like that, for like, and this is the kind of like real world application that we see. So like, we're on GitHub, we have these nice academic applications, but out in the real world, people like our Brazil club owner want to actually do this, and like we're definitely not there yet. But it's exciting, and I think like a longer lived Re-ID is definitely something that could add a lot of value to tracking. So
Well, I mean, if I was you, I would just tell your friend in Brazil, look, we really have to go out and, there's going to be some manual. We've got to have boots on the ground. We're going to have lots of caipirinhas, and we're going to have some...
Right? We're going to have to send an intern there, I think, to count the crowd instead.
Fantastic.
Until the re-ID is ready.
Okay, Ultralytics website. Look out for your friends' internships. So I'd like to move on to the next point, because it might be of great interest to many of the people in the room and tuning in online. Are there any plans, I don't know who wants to jump in here, are there any plans to include modules for object counting and analysis that are actually tailored for various use cases? I mean, you mentioned the use case of a nightclub in Brazil, which is my kind of a use case. Bo, what say you? I haven't come to you in a moment. Is this something that is in your wheelhouse?
Well, just like Given said, I think downstream tasks can be easily built on top of the current YOLO base. And first of all, Reid is indeed popular, and for object counting analysis, and unfortunately not just yet, but our future plan will be laid out mainly around the overlap of community and internal demand. So we shall see if it rises to the top of the desk.
Nice. Okay, great stuff. Watch the space. Did you want to add something there?
No, I've got another real world example. It's kind of funny. So we talked to an agricultural user who's using YOLO to kind of like watch livestock, and he's using tracking. It's built into YOLOv8, and he's got like 20 sheep in a pen, and he's got track IDs on each one. And initially they start good. They're just 20 tracks. But at the end of the day, like they're on like track number 800 or something like that, because like a sheep will cross behind another sheep, and hard to tell sheep apart. And so it's a difficult problem.
None of this sounds easy, I have to be honest. I'm very impressed. But talk to us a bit about, embedding embedded devices and YOLO when it's deployed on embedded devices. Are there any kind of performance outcomes there that we know about? Who wants to jump in?
Yeah, so I think that one of the things that we did when we designed YOLO-NAS is to make sure, I guess everyone did that, but to make sure that it can run on any device, like that it will be compilable to CoreML, TensorRT, OpenVINO, ONNX, TF-Lite, and all those frameworks, that you can simply convert the model and take it to the edge device to run. And then the last piece of it is like, what will be the performance, or how strong is that edge device? And specifically for that, the collection of models that you have, like the small, medium, large, giving you a choice of a trade-off between the accuracy and latency. So if you're working on a weak device, you can take the smaller model. You're compromising a little bit on accuracy, but you can run in the performance on the edge device that you need. And if you want to go to a larger model, or if you have a larger device, basically you can go with the larger models. And another aspect that you can take into consideration is what is the image resolution that you're working on. If you're working on detecting larger objects, you can downsize the image, get better performance on the edge device, better processing, and not losing anything because the objects are naturally large. But if you're looking to detect some small objects, you'll probably need to work with the larger possible image resolution. So that's another trade-off that you have to manage when you go to edge devices with deployment. So first thing is compatibility, second thing is performance and the trade-off with accuracy, and the last thing is the tuning, which could come from image resolution or any aspect that you can control off in order to play with that ratio or trade-off between accuracy and latency.
Nice. Okay, thank you, Yonatan. That's fantastic. And we're going to move immediately on. I've got a question literally with your name on it, Bo, because it's about YOLOv6. Now, a couple of weeks ago, you introduced a segmentation module, or YOLOv6 introduced a segmentation module. Can you share some details on the enhancements and improvements that have been made and incorporated into this specific release?
Thanks, Jocher. Yes, indeed. As with the latest release, we include a mask branch in parallel with the regression branch, which generates prototype masks, similar to the famous segmentation method YOLACT by Daniel Boya. In addition, we adjusted some training strategies like data augmentation, loss weights, etc., thanks to the strong capacity of our networks, and some useful training strategies like label assignment. YOLOv6 achieves the state-of-the-art performance for real-time instant segmentation.
Sweet. Well, congratulations. That's brilliant news. Thank you so much. And, moving swiftly on, we're flying through these questions. We're talking about real-world use cases of computer vision, accuracy, and speed when it matters the most. What are some of the best techniques that can be used for model selection. Who wants to jump in on model selection? I feel like I'm doing a quiz here. This is great. I don't know any of the answers, and you all do. Who wants to jump in? Model selection.
I would take this.
Thank you, Bo. Brilliant.
So basically, YOLOv6 actually is born to be advantageous to profit the evolution of high-end computer devices. In terms of selecting the models, we have to take the latency and throughput for sure as the constraint. We have to measure them in advance. We use the traditional roofline analysis. This is going to be a useful tool to find out whether our model design fits for the specific hardware. This gives us also a guideline in the design of the model as well. So for the selection, it's important to find the specific use cases, like or as well as available resources, performance requirements, etc. It's better to experiment with the different approaches and evaluate the trade-offs between accuracy and speed. In order to find it optimal, we have to actually do a lot of trial and errors. For example, conducting benchmarking experiments on the targeted like the tasks, different data sets. We have to select different models. This will compare and identify the models that will finally perform, whether directly targeted on our devices. If we are going to find the accuracy is met or the speed is met. So basically, there are a lot of trial and errors. Thanks.
Awesome, Bo. Thank you very much. Yes, Glenn.
Yeah, so I think the most important thing when you're evaluating different models is just how simple it is to just get that first result. And I'd say if there was just a single #1 thing that I prioritize when we're developing YOLO, it's making it simple. And in that, then I think that makes it easier for people to evaluate it, just see what kind of result they would get, and then go from there. So I think that first hurdle is always the most difficult, especially if you haven't used the technology before. So.
Word, absolutely. Convenience is perennially the killer app in 2023. So now it's time to get our many viewers who are joining us via the live stream, our folks right here in Google Startup for Campus, Google for Startups Campus in Madrid. To get them excited, it's time to open the kimono and talk about any new modules that you are developing that you would like to reveal here to our VIP audience. Who's going to jump in there and share something new, something exciting, something coming up they should know about? I'm looking at all of you.
So we've, let's see, so most of our roadmap is actually public. It's in GitHub projects. It's a little bit kind of hard to find, but if you just go to the Ultralytics repos, you'll see a projects tab, and we've got a few to-dos there, quite a few. And so some of them are kind of additional improvements in the future. And we have to kind of focus our effort between just improving the basic backbones, say adding additional tasks, improving MLOps, deploying to different places, supporting different hardware, and so on. So it's really a variety of those. Like I think one of the most exciting for me is probably just depth. So we're trying to make a depth model, YOLO depth. We'll have an app, you just point it, and it'll tell you like the depth to everything in the scene. So the main challenge there is just the wide dynamic range. So if you want to use this for like a robot that is grasping something and needs to see if it's like 10 millimeters or 20 millimeters away, or if you're also trying to figure out if that building is like 1 or 2 kilometers away, it's a very large difference. So, but yeah, so we should be launching that late this year, possibly next year. And we have additional tasks also. So some of them are action recognition, which I think is really important also, and a few other goodies, which I'll keep secret for now.
Ooh, watch this space. Fantastic. I mean, that question of depth, I just imagined a huge robot going to work on an enormous building, and, you know, what could possibly go wrong? Definitely need the depth module there. Fantastic stuff. Is there anything, Yonatan, Bo, you want to chip in there, or should I hop on with the next question? I'm going to go straight to the next question. Great. So listen, talk to us a bit about, I think you might have mentioned it earlier, Glenn, is this idea of the Ultralytics Hub. I mean, this is quite exciting, you know, this is a new development. It's a resource that folks here should definitely know about. What are your plans for that?
Yeah. So the story behind Hub is kind of interesting. So as I was working on YOLO, we started getting some interest from other startups in the space. And they had investors, and they had millions of dollars. And I thought, wow, okay, maybe we could do the same thing. And so I got a few investor contacts from the startups. We had a few meetings, and they did not go well. So I'd say, hey guys, look, I'm making YOLO. I'm trying to make this free for everybody, just trying to change the world for the good of the betterment of humanity. And they're like, okay, Glenn, what's the monetization model? And I said, oh no, we just give it away. And they said, well, that's not going to work for us. You know, come back when you have something different. And after about 5 of these meetings, I started getting the picture, and I kind of looked at what everyone else was doing, and I realized everybody has kind of like a web login and a SaaS product that you can use. And I thought, okay, like I didn't just want to kind of follow what everybody else did, but I realized that in this journey of making YOLO simpler and simpler, I was eventually going to reach a dead end, because no matter how simple you make a bunch of code, it's still a bunch of code. Someone has to come in and run it, set up environments, do a lot of complicated things. And I thought, okay, well, it's much easier to click a few buttons on a web page. And I thought, okay, well, this aligns with my mission here of making things simpler. And I thought, well, this is a great idea. So we need a second product here at Ultralytics in addition to YOLO, and that was Hub. So I conceived of it as like a no-code training tool for YOLO models that would come with an app also. I was really obsessed with this app because I just wanted to like have something in my hand. I wanted like YOLO in my hand. And so now we're working on Hub. And so the team here is led by Callan, and we're making progress, and it's pretty exciting. Like the main thesis there is just really keeping it simple too. So just simple as much as possible.
Fantastic. And I kind of feel your pain in terms of the those meetings with VCs, and they're like literally you know, thumping the table, where's the money? How do we charge for this? And, you know, ultimately to make a product sustainable, there's a lot of different ingredients, but I really applaud you for this open source mission. But I totally see the reason and the kind of the longevity factor in terms of introducing the hub and kind of broadening out the number of people who can overlap with this fantastic technology. So my dear friends, I'm afraid that is all we have time for. That has been utterly fascinating, and I hope you'll all agree that the future of YOLO Vision is like super exciting. We got YOLO-NAS, V6, V8, all these brilliant people, all the hundreds and hundreds of developers working online, coming to GitHub, you know, everyone kind of building this ecosystem. There's that old saying, the rising tide lifts all of the boats, and congratulations to all of you, and especially our 3 amazing speakers for being a big part of this rising ecosystem tide. Thank you very much to Glenn, to Bo, and to Yonatan. Big round of applause. Thank you so much.
Thank you.
Okay, well, that was absolutely brilliant. A global audience tuning in this morning in Madrid and joining us in Google for Startups campus. Do we have any, oh, it was Q&A. I'm so sorry, my goodness.
Yeah.
Do we have any Q&A? Sorry, I'm skipping between documents here. I'm not going to blame anybody but myself. Do we have any questions for Glenn? I do have some more questions. Sorry, Talia, do we have... Fantastic. Do we want to get...
Oh, that's right. Yeah, we're on
Yonatan.
YouTube also, so there may be some questions there.
Yeah,
Forgot
I'm
about
so
that.
sorry about that. Completely my fault. Okay, I forgot to write Q&A in enormous letters at the bottom of the questions.
So let's see.
So yeah, do we have any questions online? Okay, Bo, yeah, thank you so much for joining us. Goodness me, I was beginning to sweat there. So yeah, we got Bo. Brilliant. Do we have questions in the chat window? We've got Talia Bender up there, who's been doing amazing work. Hello, Talia. And with the team here at Ultralytics.
So can you hear me?
Yeah, we can hear you. That's perfect, Talia. Thank you.
So this one is going to be for Yonatan. And so someone from YouTube is asking, can you please explain the plan that you have for making these models, especially YOLO-NAS, easier to embed on Android and embedded devices?
Fabulous. Do we have Yonatan here? Because we're not seeing him on the screen.
It looks like he might have dipped out, but maybe we could loop back to that question if he comes back.
Is there a question for Bo or Glenn?
Okay, so let's see. Is there a hardware specific for using YOLO models, something affordable like under $100?
Ooh, affordable hardware. Okay.
Yeah, no, absolutely. So yeah, you can actually run YOLO models even on a Raspberry Pi. I'm not sure what the going price is. I think it might be $20 or $30. You need to plug it into some peripherals like a screen and so on. But yeah, you can get started just like that. And even on the hardware acceleration side, there's really tiny GPUs called Jetson Nanos that you can use. I think they're about $100, maybe like slightly more. So that might be technically outside of the range, but there you'll get a boost in performance. You'll have like a little tiny CUDA device running these models, maybe 10 to 20 times faster than the Raspberry Pi.
Nice. Add that to your Christmas list right now. Fantastic answer. Thank you so much. Talia, do we have, that was a perfect answer. I don't know, is there anything you want to add there, Bo? I think everyone's added those devices to their Christmas list. That's perfect. Yes, Talia.
So we have a bit more coming in right now, and this one is specifically for Glenn. Since you wanted to be a pilot, have you seen the YOLO models and computer vision being used in aviation? And do you have any ideas using them in that industry?
Oh, okay. This is really interesting. So one of the challenges, and so when I was younger, I went to the Naval Academy, and to be a pilot, you need really good eyesight. And the thing is that you want to see something very far away. And so this is very difficult in a traditional CNN, convolutional neural network, because what we tend to do is take an image at a larger resolution, downsample it, and then pass it into a model. And of course, then you're going to lose everything. So like a thing on the horizon that might be 3-4 pixels across, if you pass it at a smaller size, maybe less than 1 pixel, so it might just disappear. But I have seen applications, not specifically with YOLO, but I know like some military programs have, like specifically the F-35 in the US has 6 different cameras pointed in different directions on the hull. We're not involved with the program. I just read this in the news a few years ago. But I think also, like actually a really good example is DJI. So DJI is including a lot of vision. I don't know exactly which models they're using, but they do have cameras just everywhere on the latest drones. And they do this for obstacle avoidance, obstacle detection. And so if the drone is flying towards a tree, I think what they'll do is parallax between 2 different cameras, so they'll get a depth on an object and also just simple object detection. So I think the combination of both of those and significant field of view coverage. So I think your typical camera might be like 130 degrees. So you need several of these to wrap around to 360, not just on the horizontal plane, but vertically also. So I think, yeah, I think definitely like the biggest example I could point to is drones and the evolving use of camera systems on those. Also, even just to follow you. So there's some drones where you can kind of put yourself in the camera. I don't ski, but I've seen a video and you know, follow you down the mountain as you're doing your thing, and you can post it on YouTube and impress everybody.
I so need one of those drones for my Instagram, but it might just be films of me falling over again and again. That's amazing. And yeah, YOLO depth is coming at the right time for sure.
So this is single camera YOLO depth, which is a bit different. Oh, right, when you have 2 cameras, it works a little better. You get a bit of an advantage because the parallax effect will give you much more information about the depth of something. So closer objects will be very different. Further objects will be almost the same. So. Outstanding work. Okay, exciting times. Talia, who's next coming in from YouTube?
I'll give you guys one last question, and then we can switch to the next talk. So to wrap this up, do you have plans to train a model to detect an abstract concept like running, sitting, jumping, etc., using the pose model as a core?
Yes and no. So some of these don't require pose, and some of these can be put under the category of action recognition. So running, for example, but even a single frame of somebody running, I think you could probably also identify the action in. So this is an interesting case where you always want to use the simplest model you can. You don't want to overkill your solution. And so for running, for sitting, I think these could simply be handled by object detection or pose. But I think the higher up you get, I think on the task ladder, the higher your annotation effort is. And so if you want to annotate a data set like that, then it's going to take you a lot longer. So I always recommend start from the very beginning. If you can get away with a classification network, then use that instead of a YOLO model for detection.
Wow, fantastic advice there, directly from the horse's mouth, to use an Irish expression. That's fantastic. I think, Talia, that's all we have time for, right? We're going to move it on. Okay, thank you so much to everyone who sent in the questions. Thank you, Bo, for joining us, and Yonatan, and thank you very much to Glenn for going on the hot seat and actually completely rising to the challenge and giving us some great answers and insights there. One more time, a big round of applause for Bo, Yonatan, and Glenn. Thank you.
Thank you, Essen.
Hey. Thanks, man. That was brilliant.